So after recording and refining the list of things and determining potential attributes, the analyst needs to research and record additional information. So many important relationships among things are important to the system. So an association is a naturally occurring relationship bet between specific things, such as, in this example, an order is placed by a customer and an employee works in a department. So this is an example. The customer is Mr. Smith, who is also an employee that works in accounting department. So the is place and works in are two associations that naturally occur between specific things. So information systems need to store information about things such as employee and departments, but equally important is storing information about the specific associations between those things. In database management, the term relationship is often used in place of associations, which is the term used when modeling in UML. So in this lesson, we uses the term association because it emphasizes UML diagrams and terms. So associations between things apply in two directions. For example, a customer places an order describes the associations in one direction. And similarly, an order is placed by a customer describes the associations in the other direction. So here's a customer that places an order, and then the order is placed by a customer. So it is important to understand the associations in both directions because sometimes it might seem more important for the system to record the association in one direction or when a customer places an order than in the other direction or the order is placed by a customer. So it is important to understand the nature of each associations in terms of the number of links for each thing and in which direction. For example, a customer might place many different orders, but an order is placed by only one customer. So in database management, the number of links that occur is referred to as cardinality. So the term cardinality is it is a term for number of relationships in entity relationship diagrams, which we're going to discuss later. For example, one-to-one or one-to-many. So it is similar, it is synonym to the term multiplicity. The term multiplicity is for the number of associations between classes. So for example, one-to-one or one-to-many. So it is used in UML and should be used when discussing UML models. Multiplicity is established for each direction of the associations. The figure here shows a list of examples of cardinality and multiplicity associated with an order. It is important to describe not just the multiplicity, but also the range of possible values. So, or the minimum and maximum multiplicity. The minimum is 0 and the maximum could be 2, 1 or more, in this case order. So for example, a particular customer, let's name that customer Mr. Jones, can place no order. So in this case, there are 0 associations. Alternatively, a customer, let's name that Mr. Smith, might place 1 order. So here there's no order. So here Mr. Jones places 1 order. So the multiplicity or cardinality is 1 and only 1 associations. So also another example that is a customer can order 1 or 2, 3 or more, or even more orders. So more orders. So the multiplicity is 1 or more associations. So here, no order, that is the minimum association. Another one is 1 and only 1 association, and 1 or more associations. So the 0 is the minimum multiplicity and more is the maximum multiplicity. So 0 is minimum and more is the maximum. It could be a lot, so even up to 100 orders, 200 orders. Well, that's the maximum multiplicity. So these terms are referred to as multiplicity constraints. So in some cases, at least one association is required, or that is a mandatory, as opposed to optional association. For example, the system might not record any information about a customer until the customer places an order. So therefore, the multiplicity would read customer places 1 or more orders. So again, if there's no order, then the system will not record that customer. But if the customer places an order or 1 or more order, then the system will record that the information about the customer. So a one-to-one association can be refined to include minimum and maximum multiplicity. So 1 to 1. So for example, an order is placed by one customer. It is impossible to have an order if there is no customer. So therefore, 1 is the minimum multiplicity, making the association mandatory because there cannot be more than one customer for each order. 1 is also the maximum multiplicity. So sometimes that association is read as an order must be placed by one and only one customer. So let me write that. An order by one and only one customer. So that is for one-to-one association. So the associations described here are between two different types of things. For example, a customer and an order. So these are called binary associations. So sometimes an association is between two things of the same type. So for example, the association is married to, where can I write that? For example, two persons are married which is of course between two people. So this type of association is called unary association. So and sometimes called a recursive association. Okay, so an association can also be among three different types of things when it is called ternary association. So it is three associations of, or among any number of different types of things. So it is called n-nary association. So n could be any number. It could be 4,